All right, here we have exponents. Let's do a little instruction on what they are. Way back when you did 2 plus 2 plus 2, and you're like, oh, 2 plus 2 is 4, plus 2 is 6. And you get 6, just like that. And then a little bit later in your life, you realized, or somebody told you, hey, this is 2, but it happens 3 times. And you get 6 there. And repeated addition was called multiplication. And so then you had to memorize these multiplication tables and start growing and developing in whole new ways. Well, if you do it the same thing, but this time 2 times 2 times 2, well, you get 8. Instead of saying this is 3 times 2, because it's not, it's instead of repeated addition, it is repeated multiplication, and it happens 3 times. The way to write that is known as an exponent. So when you see this written out, that's an exponent, that 3 up there, exponent. And this is called the base, the number that is being exponented. And so this guy right here, if you write it out like that, it's called expanded. And then that guy is the end result, the answer, or what happens when you have evaluated it. So you can see that there are 3 E's that go along with exponents. Expand it, evaluate it, exponent, exponential notation. So if you see something like 3 to the 4th power, well, that is right now an exponential notation. Expanded is 3 times 3 times 3 times 3. And there are 4 of them. If you multiply this out, you get 3 times 3 is 9. 3 times 3 is 9. Times those two together, 81 is what it is evaluated. Let's do one more problem here. Let's take 8 to the 3rd power. That's 8 times 8 times 8. There we go. 8 times 8 times 8. 8 times 8 is 64. So we got to take 64 times 8. Going to have to do that by hand. 8 times 4 is 32. 8 times 6 is 48. Plus 3 is 51. We get 512. And there you go. That's the multiplication of them. Here's one that happens quite often. 10 to the 5th power. Anything to the power of 10. 10 times 10. Let's expand it out. That's 4 of them. Now 5. 10 times 10 is 100. When we times by 10 again, we add another 0. Times by 10 again, we add another 0. Times by 10 again, we add one more 0. And we'll notice 10 to the 5th is 1, 2, 3, 4, 5 zeros. 10 to the 5th, 8 to the 3rd, 3 to the 4th. And you can do that with any kind of numbers at all. Now, going backwards of this, it's kind of fun. You can actually take this 512 and move it backward, or this 3 to the 4th. As we're doing those, let's put one more up here just so we have a good 5 to the 2nd power. That would be 5 times 5. Most of those you can do in your head. When something is raised to the 2nd power, you 5 times 5, this has a special name. It's called squared. And what's really happened is you've taken a 5 and made a square out of it. And you have found the area. So 5 squared, that's where you get 25. The one over here, when it's to the 3rd power, is called cubed. So 8 cubed. And really, you've taken a cube, or taken 8, and made a cube out of it. And 8, 8, 8, 8 times 8 times 8, you've calculated the volume. So that's why to the 3rd power is called cubed sometimes, and to the 2nd power is called squared. Well, we can do the opposite. This thing right here is called a square root. So you go backwards, or find out, like if this is the result, you go backwards. Square root of 25 would equal 5. The square root of 64, what times itself, or what squared would equal 64, and that would be 8. And then this goes into these other bigger ones. You can actually do with a little 3 here, it is the cube root of 512 would be an 8. Or up here, it would be the 4th root of 81 equals a 3. Here, the 5th root of, let me see, what is that number? 100,000 is 10. So roots go backwards on exponents, and exponents are just repeated multiplication. There you go.